Good day everyone, I am Francisca Lamos Tibahenteng, and in this video we're going to talk about how to calculate the area between two curves. So let's go over the basics. So let's say we have some function f of x. Of x, and we want to find the area under the curve from A to B. So we're looking for the area of the shaded region, this one. So the area is simply the definite integral from A to B of f of x dx. So we have area is equals to integral of from A to B f of x times f of x dx. So now let's say if we have another function from A to B, and let's call this function g of x rather. This is g of x from A to B. So the area of this curve is going to be the integral from A to B of g of x. Integral from A to B g of x of dx. So it happens if we want to find the area between two curves. So let's say if we have both f of x and g of x, so it's gonna be like this. This is f of x and this is g of x. So how can we find the area between these two curves? So this is from A to B. So all we need to do is take the difference between this area of f of x and g of x, and we'll get the area between f and g of x. So that the area is simply the integral of from A to B f of x minus g of x rather dx. So that's how you could find the area between two curves. So let's say if we have another function, this is f of y, so we call this function of f of y rather, this is y. So we call this function f of y, and let's say if varies from C to D, so with y-axis. So let's assume that this is the y-axis and this is the x-axis. Then the area of that region is going to the integral of from C to D f of y dy. So that function is basically x is equals to f of y. So now let's say if you want to find the area between two curves, so let's say if we have f of y and g of y. This is g of y, and this is f of y. going from C to D. So instead of taking the top function and subtracting by the bottom function, what we're going to do is we're going to take the integral. So we have this integral from C to D f of y minus g of y dx. And that's how we can get the area between two curves from C to D. So we have an example. So calculate the area of the region bounded by the line y is equals to 8 minus 2x, the x-axis and the y-axis. Let's get the x and y intercepts since we are dealing with a linear equation. So when x is 0, this is going to be 8 minus 2 times 0, which is 8. So we have 0 and 8. So, and if we replace y with 0 and the value for x, we can see that x is going to be 8 divided by 2, which is 4. So we have this 8 2x is equals to 8, then yes. So we have y-intercept of 8 and x-intercept of 4. This is 8 and this is 4. Y-intercept and x-intercept. So we want to find the area between the x-axis and y-axis. So we say we can do this is through use the geometry. So when know that the area of a triangle is 1/2 base times height. So we know that area is equals to 1/2 base times height. So our base is 4, then our height is 8. So 1/2 times 4 times 8 is equals to 16. So this is the area of shaded region, which is 16. But let's use calculus to get the answer as well. So we know that area between a curve and the x-axis is going to be the integral from a to b of f of x dx. From a to b of f of x dx. And as we know, y is equals to f of x, and y is 8 minus 2x. So f of x can be replaced with 8 minus 2x, and along the x-axis we're gonna integrate it from 0 to 4. So we have this integral of 0 from 0 to 4, 8 minus 2x dx. So the antiderivative of 8 is 8x, and the antiderivative of 2x to the first power is 2x squared over 2. So we have this 8x 2x squared to integral of from 0 to 4. So we can cross out 2. So it's just 8x minus x squared. So let's integrate the 4 squared minus, let's integrate the 0 minus 0 squared. So 8 times 4 is equals to 32. 4 times 4 is equals to 16. Then 8 times 0 minus 0 squared is equals to 0. So, 32 minus 16 minus 0 is, it would be 16. So, our answer is correct. It's 16.